Now and again on Tinfoil Tuesday, we take a look at people who are just trying to make sense of the world around them. And that is absolutely fair enough. But to do so without even taking a single look at the actual science that's gone on to figure this stuff out is simply foolish. Today's guest does exactly that as he discusses positive and negative energy of the sun and moon. Hello all and welcome along to another episode of Tinfoil Tuesday with me, Simon Dan. Thank you very much for joining me. Before we begin today, it is with great sadness that I recently discovered that the amazing James Randi passed away last week. In my opinion, the absolute king of debunkers. Rest in peace, sir. Right, let's crack on, shall we? The Controversy of Truth is a YouTube channel that wants to tell us all about what is really going on with the sun and the moon. Let's hear him out, shall we?
Howdy. Well, I'm going to try this without a script. Hope I don't mess up too much. Hey, so the subject I want to talk about today is the sun and the moon. The sun and the moon. So first off, I want to go by what I was told growing up, that the sun's hot and the moon is reflecting the sun's light.
Spot on. Continue.
And the sun is very far away and the moon is closer.
Also correct. Nice start.
But, you know, as I've gone on in my life, observations I've made, something hit me one day. I was in the Peruvian Andes. And if any of you have been to Peru, you'll know that it's a tropical country, quite warm and sunny, it seems. At times rainy, but when I was there it was sunny. I went from the lowlands up into the highlands. And I will tell you, I decided something then and there that started making me think about the sun. The higher we got, the cooler it got.
Oh no, I think I know where this is going.
And by the time we were up where trees don't grow no more, it was cold. You know, there's ice, snow that doesn't melt on those mountains. And I started thinking a little bit. You know, we're going up. We're getting closer to the sun.
I don't know what mountain you were climbing in Peru, but even if it was the highest one, then the distance covered vertically compared to how far away the sun is would be incredibly tiny. In fact, climbing the tallest mountain in Peru would be 0.0000045% the distance to the sun.
They tell us it's because of the atmosphere, the coolness. As we get higher, I thought, well, but we're sure close to the sun should still be warm.
Well, this is true. As you go higher, the atmospheric pressure decreases. When the pressure in a gas decreases, the temperature does as well. Interestingly, because of Earth's orbit, if you would have climbed that mountain in March, for example, you would have moved further away from the sun in our orbit, completely negating the amount of distance you would have climbed getting closer to the sun in the process of climbing it.
Then it hit me. Maybe we're looking at this wrong. And let me tell you what I come up with. And I've never really heard anybody else talk about this, so I don't know if you've heard it before.
Well, there's probably a reason for that.
But I thought about two things. One, the highest places on Earth are the coldest.
Correct, because of the air pressure temperature thing I mentioned earlier.
In the tropics. The warmest places on Earth, or well, I'd say in the U.S., is Death Valley. Has the highest temperatures. It is also the lowest. Now, if any of you have traveled a lot, you'll notice that the higher altitudes you get, the temperature drops. And I was thinking, well, what's causing this?
The Earth absorbs a lot of heat, so when you're standing on it, then you're obviously going to feel that. Couple that with the atmospheric pressure point from earlier and you can see why.
And then, after realizing one thing, it started to make sense. The sun is positive energy. So when you set up a solar system, you have your positive and negative wires, and if you plug in or hook up to the battery, the positive and negative, your panels with a charge controller will make electricity. If you unhook the negative wire, the positive no longer does anything.
I think I understood that. The sun does actually have a slight positive charge, but make no mistake, that's not positive energy.
And I thought, well, if you look at the Earth and the way things are, you'll realize that the Earth is a negative energy plane.
Well, no. The Earth's surface is negatively charged and the air above the Earth's surface is positively charged.
The sun is positive. And as you go up in altitude, further from the Earth, the energy of the negativity of the Earth becomes less and less and less until you reach tree line and beyond, where it's no longer very much of it. And so the reaction of the sun's positive energy does not have much effect.
Look, I think we can step in here and say that there was not really much substance to that explanation. Pretty much word salad. You're looking for answers when there are already some here.
So as the sun's ray, or the sun's energy, comes into our Earth's atmosphere, the closer it gets to the Earth, the more it heats up.
What? That makes no sense.
So for example, you feel the sun hit you, you feel the warmth of the sun. It's the reaction of the negative and positive energy.
No, it's the radiation from the sun hitting your face.
Our bodies are their own energies to themselves. We'll get to that in another subject, another video. But what I want to point out is the trees and the plants, when they're grounded in the earth, they take the sun in, and through photosynthesis of the negative and positive make energy to feed them. So, in a sense, the sun is not hot. The sun is positive energy, and as the positive energy comes in contact with negative, it creates heat. So the lower you go, down to the negative energy plane, the hotter it gets.
Dear oh dear, he's making a right mess of this. I genuinely do not mind that he's trying to figure this stuff out. But random ideas are not going to cut it. I mean, fair play, his imagination is great, but it's not very scientific.
If you watch lightning, you'll see the lightning will go up and it will spread out on the positive energy plane. Okay, that brings us to the moon.
Let's brace ourselves for further theories.
They say the moon reflects the light of the sun. Well, if that were the case, the moon would be the same as the sun.
Why would it? The sun is a giant nuclear reactor. The moon is not.
But in fact, in reality, the moon is the opposite of the sun. The energy being given from the moon is negative.
And you know that how? We actually know very little regarding the charge of the lunar surface.
And it wanes and wanes. As it wanes, the sap on the trees runs down. As it waxes, the sap runs up. So in essence, when the moon is full, it pulls the energy plane of the earth up.
I'm sorry, but the forces involved in moving plant sap far outweigh any influence the moon would have.
Which in turn causes the cycles in many animals and people, and in plants and bugs. So, my understanding is the moon is negative, the same as the Earth. It gives its own light. The light is white, and if the moonlight is compounded to a point through magnification, it cools.
Incorrect. And if it's white light, then how do you explain this?
So a thermometer's temperature will drop up to 8 degrees under moonlight.
Radiative cooling. Debunked this many, many times.
Where sunlight, when concentrated, will burn and produce great heat. And actually looks black, dark, at a point. So they're two very different energies.
Except they are not. It's the exact same light, I'm afraid.
And, I found it very interesting. We're told the sun is 93 million miles away. And so I decided to do a little bit of my own research on this.
Oh, here we go.
I put in a pole, 20-foot pole, and I waited till equinox, at the time when the sun would be directly overhead on the solar equinox, where the sun would be at a place where I could measure the distance from where I was, from the equator to my place. Then I measured the shadow of the pole, and with the help of a friend, I triangulated the distance or the height of the sun would be at its specific place at the equator from my location. And I got between 2,600 and 3,000 feet based on elevation, which I had a hard time deciding 100% where I was.
So Everest is taller than the sun's height. What happens when the sun needs to get past? Does it just nip around it?
I didn't have that. But based on sea level observations, it would have been approximately between 2,000 and 3,000 feet, depending where you are, above the Earth. No, I'm sorry, I said it wrong. 2,000 and 3,000 miles.
Ah, okay, now we're getting somewhere. 2,000 or 3,000 miles. Would love to see the calculations for that height.
So that would tell me that the sun is not 93 million miles away. And neither is the moon. In fact, the moon and the sun are a similar size, and they both circle the Earth at a very similar speed. The sun makes its rotation in 24 hours, and the moon makes its rotation in 25 hours.
Nope, I see where this is going. Not today, thank you, the controversy of truth. That was a very long way to tell us you're a flat earther. Well, there we go, another brilliant episode of Tinfoil Tuesday done and dusted. Really enjoyed that one. I hope you did too. If you did, then please do like and subscribe. It would be thoroughly appreciated. I've been Simon Dan. Have yourselves a great week, and I'll see you on Friday for a bit of a high-profile YouTuber debunking. See you then.